Yeah, thank you. We definitely want to have something to share with you guys. It was a very special machine. I've been in this industry for 17 years, and over the years, I've seen laser scanners from many manufacturers. And of course, RIEGL has an extensive product line from aerial, unmanned, mobile, and of course, tripod. I'm the division manager for our Terrestrial Laser Scanning Division, and this is a very special equipment. In the past 17 years, I've seen challenges, right? I've seen a lot of changes, adaptation stage. I've seen stages where we were marching to the DOTs, trying to get them to accept this technology. So I've seen the gruesome challenges over the period of time. And you know what? These laser scanners, they all really produce a nice point cloud, right? At the end of the day, they're accurate, they're precise. So I think what I encourage customers to do is when they are looking at a new system, the key word here is productivity. I think now that we don't need to invest our time, our effort, our money into researching LiDAR anymore. I think it's mature enough at this point, so that I think when we are looking at a new system or want to adapt a technology, I think productivity is key. And this machine, I believe, is a fine example of a very productive machine. Just looking at the interface itself, it's very economical. One-touch button operation, meaning that you can literally put 5 steps on a card, and anybody can open it, set it up, self-leveling, and they can use it to collect data, right? You can see here, the front has 3 internal cameras, but you can see on this display, there is also an external camera too as well. The external camera is just a Sony option. It's very good for industry, such as oil and gas, architectural facade, or interior modeling. So you get a really high quality image scanner, and you also get a high speed scanner too as well. The system itself is quite light. You can see here, the system itself is very flexible, right? So we want to give the flexibility to the ownership of the customer. So the customer can choose to scan at any pulse repetition rate, which dictates the range, right? So if you know RIEGL, you know RIEGL can shoot up to 1,000 meters, particularly with this machine, but you can also scan at a half a foot, right? So it's a very dynamic system in ranging aspects. Simply select the pulse repetition rate at 2200 kilohertz, all the way down at 100 kilohertz, then you can shoot out to 1,000 meters, right, if you ever need to. And there's certainly applications for that. In fact, we just released a brand new scanner that can shoot up to 4,600 meters. Now, of course, you wouldn't use that for your everyday surveying. Probably 99% of your survey is probably within the 2200 kilohertz mode. But you can see here, this is a special mode that you can turn it down to less than 1 millimeter precision by enabling the high precision mode. Right, so the scan is very, very special. The accuracy and precision, it's pretty much the same all across the board with all your manufacturer, but when you need that extra sub-millimeter accuracy and precision, there certainly is an option for that, and I can see that happening when you're doing floor flatness, right? So these great big Amazon warehouses, when you need to scan and look for the floor flatness, this is a very key aspect, tool that you can use to measure the flatness of the concrete floor. Other notable specs on the performance side is speed, right? So my title says speed, accuracy, and productivity. I think these scanners really need to be productive, right? Because when you're creating these BIM models, these digital twins, right? We're talking about digital twin for the last years now, right? You got to have a system that can really perform and really scan a large area in a respectful amount of time, right? So when you go into these large facility, 100,000 square foot facility, you got to have a scanner that can really cover, not only cover, but can also, do it fast. And you don't want to interrupt production on like a GM plant, for example, or a Toyota plant. You don't want to interrupt production. So you got to have a system that can be very, very productive. You can see here the specs are highlighted, right? So on paper, you can scan a minute per scan position, but I'm going to show you later on in some real-world tests that I've personally done myself over the summer. Scan time is less than 30 seconds. So in 25 seconds, you can complete a 360 degrees revolution scan and also capture the images at the same time, right? So now that you have the time, you can then quantify how many setups you need throughout the entire project, right? And you can also say, hey, this thing should be done in 5 hours because you know how fast it scans in 25 seconds collecting images at the same time. Now, that is just not any scan, right? That's a 6mm resolution at 10-meter range. So we're not just giving you a high-speed scan at low resolution. 6mm at 10-meter range is considered medium to high resolution, right? Moving on to some other specs, of course, 16 pounds is a big deal for us because in the past, our scanner is a little bit on the heavier side, but with this new generation, it's very portable and travel-friendly, and of course, still maintain a high IP64 rating. So when you're scanning in harsh environments, where it's very dusty, like power plants, coal plants, whatever, this is a very good machine that can withstand such a diverse environment. Okay, so just to get us some real-world numbers, right? So I did this personally myself. So total of 9 projects, 466 scans, and 520 minutes. Everything is documented. Everything is very transparent with our machine. When you download the data, there's a lot of metadata involved. There's a time stamp down to the seconds, date, of course, everything. Transportation project, so 243 scans, and covering 3.3 kilometers and 390 minutes. Indoor projects, I did 502 scans, and it took me about 5 hours and 68 minutes. And in total, 1,211 scans, sorry, 1,211 scans positions, so that's setups. Took 1,478 minutes. So the average out, it's about 1 minute and 22 seconds per setup. So when I pick it up, I put it back down, that's 1 minute and 22 seconds. So you can kind of quantify how much scans how much time it needs to cover, for example, this entire building, right? And of course, our scanner works on line of sight, just like every other system on the market. And then I'm going to leave you with this highlights, right? So I'm going to go ahead and scan now. Okay. So what you're looking at here is that from the top down, you have a differential GPS, so that's an L1, L2 RTK receiver. And in the middle is your high-resolution image camera, RGB. So you don't have to have that. You can just use the internal camera. And then you have your laser scanning part, which is 105 degrees vertical window. And you can see it's already 3/4 way done with the scan. In just about 4 more seconds, it is completely done. That's it, right? So not only that this is scanning, it's also registering the data together too as well. So by the time I pick this up, and put it over here. Scan now. The data, this doesn't have voice command, by the way. I don't know how I'm doing that, but yeah, so it's gonna go ahead and register the 2 data sets together without the use of any targets. Now, when I say, this can measure out to 1,000 meters, and there's gonna be people that say, hey, I don't need that range, right? You actually kind of do, right? Whether you like it or not, you actually kind of do. That's how our registration works so well, is because it uses dynamic ranging and facade from long range and also short range to really stitch this two together. In fact, by the time I download the data into my laptop, I do a cross-section, I was certain to be less than 1 millimeter of noise, even with multiple scans already together. And that's it. That's 2 scans right there. From there to there, that took less than 1 minute. So you can see how productive the system can be. And I encourage people to look at productivity, because productivity does not just stop and start in the field. It actually starts in the field, but ends with a deliverable too as well. So you can collect the data all you want, but if it takes you 3 times to process the data and to give it a deliverable, you're not looking at productivity. You're just looking at another scanner that, that's been around for a while. And like I said, I've seen it. So we try to make the productivity ends with a deliverable, either LAS, E57, LAZ, PTS, PTX, and so on, either to the end clients or to internal for use. So I don't want to keep you guys more longer than I have to. I know it's lunchtime, so thank you for your time. And please, if you want to take a closer look, we have the scanner upstairs. It's a working system. And we also have this thing in a kinematic mode too as well. And I didn't talk much about that today, but there's also a mobile scanner as well. And I've done some great projects with this on a bridge, right? So we've done a little bridge scanning where we can scan the parameter on shore with the tripod style. And then when we're done, we'll just put it in kinematic mode using RTK. You can hit RTK correction either from an N-chip signal or from a dedicated base broadcasting an N-chip signal at the moment, right? So there's no radio correction, just N-chip correction for RTK. But yeah, you can also put this thing on any moving platform. Of course, the speed is recommended to be less than 20 miles per hour, but then you can scan and survey at the same time without any other additional hardware components needed. Internally, there's actually 2 IMUs that can track the trajectory and the motion and the travel of the scanner. And then we just post-process the data using the accuracy of the data to realign and redefine the trajectory as a mobile scanner. So as this, just how it is right now, it is also a kinematic system too as well. So thank you.